For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
The last operator we're going to talk about is the double implication operator, also known as the biconditional operator. Why double, why bi? Because it looks like this. It has double the arrows. So regular implication looks like this, double implication looks like this. It has double the arrows. You may also see it looking like this sometimes. Now, how do I create a truth table for this compound proposition? Well, I see two propositions, so I'm going to do two columns for each of the propositions that I have, and I'm also going to do one column for the compound proposition itself because that's what I want to actually find the truth values of. How do I fill in the table? Well, first of all, how many rows do I need? The number of rows is always equal to 2 to the n, where n is the number of propositions. We know that we have two propositions, so that's 2 to the second power, which is equal to 4. So we're going to have 4 rows. Now, how do I fill up the table? You take your number of rows divided by 2, and you're going to write it down under the first column, and then keep dividing by 2 until you get to 1. This 2 tells you how many truths and falses you're going to have to start off with, and you always want to start with your truths. So you're going to do 1 true, 2 truths, you used up all your truths, so you move on to your falses. 1 false, 2 false, you used up all your falses. You're done with this column because you ran out of space, so you move on to the next column. Here, this tells you how many truths and falses you're going to have to start off with. You're going to do 1 true, I used up all my truths, then you move on to your falses, I used up all my falses. There's a problem, we still have space left. What do? We copy and paste the exact same pattern that we have written right here until we run out of space. We did, so we're done with this column as well. Now, to find the truth values of this implication, the way that I think about it is that when we're dealing with double implications, the double implication is looking for twins. So think double, think twins. So the double implication is going to return true, is going to be happy if it sees twins like true and false and false. So in this case, I see twins, so it's going to be true. In this case, I see twins, so it's also going to be true. Otherwise, it's just false, because in both of these cases, they're not the same. So only when we see twins is the double implication operator happy, and it's going to return true, which further supports the fact that when we read this as E implies Q and Q implies P, because it's a two-way street. Also note that this operator can be read as if and only if. So fun fact, when we write definitions in this class, definitions can only be written with if and only if, this operator. So keep that in mind, and we'll talk more on that when we get to the proof lesson, which is when we start writing definitions.